Thank you for joining me today. My name is Chris Walkwitz, and I'm a machine vision expert with DataLogİC. I want to show you how and why machine vision is used in the food, beverage, and packaging industries. First off, let me share what a typical machine vision system on a water bottling line might look like. The bottles are moving down this conveyor at extremely high speeds. In fact, hundreds of bottles per minute is the norm. The cameras, which are located just to the side of the red illuminated bottles, inspect the bottles and reject any bottles that do not meet specification. Here's a bottle that gets rejected. Oh, that's always awesome to see. So, other than it being fun to watch, why install machine vision on a production line? Well, I could tell you all about increased throughput, higher yields, and customer satisfaction stories, but instead, let me break down some typical numbers to show you a cost savings. With a line moving at 600 bottles per minute, it is not uncommon for a machine vision system to detect 2 or more defective bottles per minute versus a human inspector. Now keep in mind, these bottles ship in cases of 24, and defective bottles that are sent to customers can result in return cases. So we can easily say machine vision can catch an extra 2 cases per minute versus human inspection. Conservatively speaking, it costs at least $1 to deal with one rejected case. This equates to $2 per minute. Now if I punch this into my calculator and assume 351 days of production per year, I am left with an incredible savings just by reducing defects. For plants running 3 shifts, we are seeing a savings of $800,000 per year and $530,000 per year for a plant that runs 2 shifts. The bottom line is this: the return on investment is short, and to be competitive in the marketplace, you really need machine vision. Let's take a look at how machine vision cameras can be configured on a production line. This diagram represents a production line. The bottles would be moving from left to right, and the first thing that would happen is a sensor would trigger the first camera to take a picture of a label. The second camera would also be triggered by that sensor and would take a picture of the cap. Those images get sent back to the processor, and the processor would make a decision as to whether the part was passing or failing. If it's failing, it gets rejected. And the user interface updates with each image to show the operator what's happening on their production line at any given time. I now want to give you a demonstration of how to program the cameras for a bottling application with Impact Vision Program Manager, or VPM. The bottles I will show you are from a real application. Alright, I'm now in Vision Program Manager, and we're now going to set up the program so we can inspect the bottle cap. So the first thing we need to do is locate the cap within the field of view. Every bottle is going to move a little bit. So I'm going to go ahead into the locating toolbox, grab the pinpoint pattern find, and drop that out into my program. I'm going to follow the steps here and go to train ROI. I'm going to go ahead and train it just on the cap. So I'm going to adjust this ROI, also known as region of interest, over the bottle cap. I'm going to tell it a few parameters. The bottle cap can rotate a few degrees, and there can be a little bit of scaling. I'm going to go ahead and hit train, and you can see on the image it trains the model. And now I'm going to come to the third step. We need to tell the program where to look within the field of view. So we know it's going to be somewhere up in this region, so I'm going to go ahead and adjust that. Next thing I'm going to do is I'm going to look for debris along the side of the cap, any kind of plastic that's hanging off. We want to catch that. I'm going to go into my feature finding toolbox and grab a blob tool. Follow the steps through. I'm going to grab my region of interest, and I'm going to position it just off the side of this bottle cap. And I need to tell it what intensity of pixels to look for. So when I mouse over my image, you can see in the top right-hand corner, there's an I, which stands for intensity. And as I go over dark regions, it approaches 0, so 0 is black, and over white regions, it's 100. So I know from prior experience, it's somewhere in this 75 range. So I'm going to take this region of interest and copy it. I just did that on my keyboard, Control-C, Control-V. I'm going to go ahead and create one more region of interest. Want to catch anything on top. Next thing I need to do is say how many pixels are we going to count as a blob or as a defect. And we're going to say anything over 25 pixels anything to infinity. So from 25 to infinity, that's a defect. And we can have a minimum of 0 and a maximum of 0. Anything more than 0 is going to be counted as a defect. So let's go ahead and snap through our images. Great, and you can see we had some plastic hanging off. We caught that. Looks like this is working great. Next thing I want to do is drop in an average intensity tool, and I want to check just to make sure the cap is there. You saw in one of the images that it was not. So I'm going to drop this region of interest right over the top of the cap. I'm going to go ahead and train the tool. And basically what we're doing here is we're saying the average intensity within that region of interest is approximately 11 on a 0 to 100 scale. And we can say plus or minus 10. So let's go ahead and snap through these again. You can see they're all passing until we get to the one missing the cap. If we look down here, it's reading an average intensity of 52, which is outside of our tolerance, so that's failing. That's good. And the last thing I want to look at is sometimes the caps get bent. What we're going to do is drop in what we call a line find tool. Take my region of interest. I'm going to move that over the top of the cap. And I need to tell it to look for a dark line. Right now it's looking for a bright line. And now what I need to do is set some tolerances for this tool. And really what I want to look for is straightness. Right now the straightness is about 0.68. I know that anything over 0.8 is really going to cause a problem, and that's just from testing on the production line. So let's go ahead and run a few. And you can see that this top of the cap is bent, and it failed because of this straightness error. So we've now created a full inspection. I'm going to go ahead and put a little bit of logic to pass and fail the tool. So I'm going to drop in what we call a pass-fail tool. We're going to drop in a tool called the discrete output tool. And we're going to pulse output 1. Now that we have a working program, I'm going to go into a display feature that we have in VPM. So let's go ahead and snap through and we can see the whole program in action. You can see here we're catching the defect there. Again, catching the defect on the right side, catching the bent cap, catching the extra band, catching the missing cap. Looks like the program is working pretty well. Let's go set up the label inspection. Alright, I have the camera set up and it's taking images, and what we're going to do here is inspect the labels. So the first thing I want to do is locate the bottle because it is going to move a little bit. So the way I'm going to do that is come under my locating toolbox, and this time I'm going to use the origin tool. I'm going to follow the steps through, and I'm going to actually use just the defaults till I get to step 3, and I'm going to position my regions of interest, or ROIs. I'm going to position 2 along one edge and 1 along the other edge. And I'm going to tell them to find a dark edge. So it's looking from the tail of the arrow towards the tip of the arrow for an edge, and I'm going to tell it it's a dark edge. So I'm going to go through and do that for each region of interest. Next thing I'm going to do, I'm going to drop in an average intensity tool. And I'm going to position this average intensity tool in a few places on the label. One, I'm going to put it right on the label to make sure the label is actually present. And then I'm going to position a couple other ROIs on the outside of the bottle, because what will happen is these labels will come loose in the back and you'll see them hanging off the side. They'll be flying off the side. So what I'm going to do is position them like that. I'm going to set the tolerance type to use nominal intensity list plus or minus the tolerances. So once I set it to that, I'm going to go ahead and hit train, and it's going to train each individual region of interest for the intensity that it sees at this point. If it's outside of the plus or minus 10 tolerance set right here, it will fail. Next thing I'm going to do is I'm also going to check the label to make sure it's straight. On occasion, there'll be issues up on top where it gets folded over wrong. And so I'm going to go ahead and put a line find tool. Follow my steps through. Let's set this up. And we'll go ahead and just leave the region of interest like that, and you can see the arrow in the center, so it's facing downwards. I'm going to tell it to look for the first dark edge. I'm I'm going to go ahead and set the edge detection type to gray level edges. That's just a different methodology for finding an edge. I'm going to go in and set up the pass-fail criteria. So you can see it did find a line here. I'm going to set a gap. We'll say a gap, anything more than 25 pixels is a failing gap. And let's go ahead and set the angle. So right now this is an exact 90-degree angle. So you can see it says actually 90 degrees. So we're going to set it at 90 degrees, -5, and +5. And let's go ahead and look at each of these tools individually. So I'm going to go back up to my average intensity tool. And you can see there's a label that's flying off, and you can see failing. And here again, the label's flying off, and you can see that just this region of interest failed because it was outside of the ±10 tolerance. And you can see a missing label, the middle ROI fails. Let's go ahead and look at the line find tool. And there it found a crooked label. There it found a label with a bad angle, and the gap was large, so it failed for both of those reasons. And so between these two tools, we should be able to catch every defective label that this side of the camera can see. Last thing we're going to do is add in the pass and failing tool, just like we did before. And we now have a completed application. Let's go ahead and look at it in the display screen. And this is a great application. The next thing I want to show you is Control Panel Manager, also known as CPM. CPM is used so people can interact with the cameras and see what's going on in real time. Let me go ahead and trigger the cameras a couple times so you can see what it looks like when they're triggering. And we can see everything we see in VPM. However, we can totally customize this panel. So for example, I have total counts, pass counts, fail counts below the image. I also have a supervisor login button. Let's go ahead and click that. This is a password protected screen, so I'm going to enter my password, click log on, and now several other inputs have become enabled for the supervisor with the credentials to log in. For example, we can reset the counters, and we can change the gap, and we can train the label. Let's go ahead and trigger a couple more times. Maybe move this region of interest in just a little closer. We'll move this one in just a little closer and rotate it just a little bit. Perfect. And let's go ahead and train that. Actually, we should train it on a good part. And let's continue running. You'll also notice I have a tab that shows the last several rejects that were saved. I am saving these images. And I'm going to go ahead and trigger the camera a couple times. And you'll see the newest reject is on the farthest left, and the oldest reject is on the farthest right. The last thing that I want to point out about CPM is that you can display as many cameras as you want. Additionally, there's no limit to the amount of customization you can implement on this user interface. Oftentimes in bottling applications, we see image saving, graphing, statistics, recipe changing, and new part configuration, just to name a few. Well, I hope you enjoyed my presentation on how and why machine vision is implemented in food, beverage, and packaging applications. I sincerely thank you for taking the time to watch. Again, my name is Chris Walkowitz with DataLogİC. I hope you have a great day.